Hello and welcome Primary 4 to another video. Our lesson today is probability. We're gonna study today how to calculate the probability. This probability is calculated for a random experiment. This random experiment like having a die. If I'm tossing a die, the shown number or the outcomes or the results is the number 1 or 2 or 3 or 4, 5 and 6. So I'm knowing all the possible outcomes coming out from the die, but I'm not sure which outcome will certainly occur. If I'm tossing a die, I'm not sure which answer will certainly occur. Another random experiment like tossing a coin. When you toss a coin, you can get a head or a tail, but which outcome will certainly occur, I didn't know. So the probability is calculated for this kind of experiments, for the random experiments, and we are calculating the probability of the outcome, and this outcome is named by the event. So if I'm tossing a die, this outcome, this is called the event. So the event may be impossible, like tossing a die and getting the number 7. The die does not contain the number 7, so this event is impossible and its probability is equal to 0. And this event may be a certain event, like if I'm throwing my phone, it will be destroyed. So this is a certain event. If I'm throwing my phone very hard, it will be destroyed. So this is a certain event and its probability is equal to 1. And the event may also be a possible event, like tossing a die and getting a number from 1 up to 6. This is a possible event. Like tossing a coin and getting a head. This is a possible event. And this kind of possible events is represented by a fraction. And to be certain, this kind of fraction is a proper fraction. And its value is between 0 and 1. So, what is probability? Probability is to calculate how likely the result will be occurred, and this results or this probability is calculated in a random experiment. This random experiment, when held, it's gonna give us an event. This event may be impossible and its probability equal to 0. It may be certain and its probability is equal to 1. And it may be possible and it is represented by a proper fraction. And to calculate the probability of a possible event, so the probability of an event A can be calculated by this rule. The number of events A, how many times that event will be occurred, over the total number of possible outcomes. How many outcomes will certainly can be occurred. So the probability of an event A is calculated as the following. The number of the event A, how many times this event can be repeated, over the total number of possible outcomes. What is the number of all possible outcomes in this experiment? You have a mistake here in your booklet. The certain event, its probability equal 1, not 0. So you have to modify it to 1. So if I'm having a coin and I want to calculate the probability of getting a head or a tail, I know that all the possible outcomes that we have, either a head or a tail. This is all the possible outcomes. To calculate the probability of getting a head, how many heads in the coin? It's only one head, so I write up here 1. How many answers that you can get from tossing a coin? You have head or tail, so you're having 2 outcomes. So so I'm writing in the denominator 2. So the probability of getting ahead is 1 over 2. 1 is the number of heads, and 2, it's all the possible outcomes. It's the same for the tail. To calculate the probability of a tail, it's just you're having one tail, so I'm writing up 1, and all possible outcomes are 2, which is head or tail. I'm writing down in the denominator 2. And there is an important notice that the sum of all probabilities of this experiment, of a random experiment, must be equal 1. So if I'm tossing a coin, I'm either getting a head or a tail. The probability of head is half, and the probability of tail is half. If I'm adding all the possible outcomes together, this probability, the sum of all probabilities, must be equal 1. Let's solve some examples in page 81. In your booklet, page 81, exercise number 1. Let's see, complete. The probability of impossible event is, before that's an impossible event, its probability is 0. Number B, the probability of a certain event is, its probability is 1. The probability of appearing ahead when tossing a coin. So I want to get ahead when tossing a coin. How many heads in a coin? We have said before, it's only one head. And how many faces? The total number of faces in a coin, we have head or tail, so it's 2 faces. So the probability of getting ahead is only one head over the total outcomes, which is 2. The sum of all probabilities of all possible events is, the sum of all probabilities is 1. If the probability of a student to be failed is 0.2, then the probability of this student to success. We have said before that the sum of all probabilities is 1. Either the student will fail or succeed. So I'm gonna subtract 0.2 from 1 because we have only 2 possible outcomes. Either he fail or he succeed. So we're gonna subtract 1 minus 0.2, which equal 0.8. So this is the failing probability, and this is the success probability. Example number 2. If you throw a die once, what is the probability of getting the number 2? So if I'm throwing a die, what is the probability of getting a number 2? How many faces contains the number 2? It's only one face. And what is the total number of faces in a cube or in a die? It's about 6 faces. So the probability of getting the number 2, it's only one face contains the number 2 over how many faces? The total number of faces is 6. So the answer is 1 over 6. The probability of getting the number 5, it's the same. We have only one face contains the number 5, and the total number of faces is 6. The number 8 on the upper face. I didn't see a number 8 on the upper face of a die. So this is an impossible event, and you know that the probability of impossible event is 0. An odd number in the upper face. So what are the odd numbers in a die? We have the number 1, this is a face, and the number 3, this is another face, and the number 5, this is the third face. So we're having the numbers 1 and 3 and 5. So we expecting to have 3 faces, which contains an odd numbers, over the total number of faces is 6. By simplifying this fraction and dividing it by 3, so 3 divided 3 equal 1 and 6 divided 3 equal 2. So when you toss a die and you are expecting to get an odd number, the half of the faces of the die contains odd numbers, so the probability of getting an odd number is half. What is the probability of getting a prime number on the upper face? The prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on. So the die contains the number 2 and the number 3 and the number 5. There is no other odd numbers in the die. So we are expecting 2, 3, 5. We are expecting 3 faces. Out of how many faces in the die? It's 6 faces, so this probability is also equal half. So the probability of getting an even number or an odd number or a prime number, either even, odd or prime in a die, its probability will gonna be equal to half. Exercise number 3. A teacher chooses a student from a random class contains 40 boy and 20 girl. What is the probability that chosen student is a girl? So the probability of getting chosen student which is a girl is how many girls in the class? We have 20, so I'm gonna put 20 up. Over the total number of students in the class, we have 40 boy and 20 girl. The total or the sum is 60 students in this class, so the total number of students is 60. By dividing by 10, we cancel these 2 zeros, and then dividing by 2 up and 2 down, so the answer is gonna be 3rd. In your booklet, page 83, let's solve exercise number 6. If you throw a dice, what is the probability of appearing the number 4? The number 4, only one face in the die contains the number 4, so we put 1 up. Over how many faces? The total is 6 faces, so the probability of getting the number 4 is 1 over 6. Question number B, getting the number 7. The number 7 is not shown in the die, there is no 7, so this is an impossible event, so the probability of getting 7 is 0. An even number on the upper face. As we said before in the previous page, that the die contains the numbers 1, 2, 3, 4, 5, 6. This all the numbers in the die. 1 and 3 and 5 are odd, and 2, 4, 6 are even, so we are expecting how many faces? 3 faces. Out of the total number of faces is 6, so the probability of getting an even number is half. A number smaller than 3 on the upper face. What are the numbers smaller than 3? It's 2 and 1, so we're expecting 2 faces out of the total 6, and by simplifying and dividing by 3 up and down, this probability is gonna be equal to 3rd. The probability of getting a number divisible by 5. So we want a number from these numbers 1 to 6. We want a number to be divisible by 5 or can be divided by 5. 1 cannot be divided by 5 and 2 cannot be divided by 5. Also 3 and 4. The only number that can be divided by 5 is 5 itself. So we are expecting 1 face out of how many faces? 6 faces. So the probability of getting a number divisible by 5 is 1 over 6. Exercise number 7. A box contains 4 red and 6 yellow balls. If a ball is chosen with random, what is the probability of having the following? First, I'm gonna get the total number of balls. We are having 4 red plus 6 yellow, so the total number of balls is 10. I'm getting this number to use it to find the probability of the following. First, the probability of getting a white ball. How many white balls there? We only have red and yellow, so there is no white balls, and this is an impossible to get a white ball, so its probability will be 0. The probability of getting a red ball. How many red we have? We have 4 red balls over the total number, which is 10. By simplifying and dividing by 2 up and down, 4 divided 2 equal 2 and 10 divided 2 equal 5. Number C, non-red ball. So non-red ball, we don't need to get a red ball. What is the other colors that we have? We have a yellow, and the number of yellow balls is 6 over the total, which is 10. By simplifying and dividing by 2 up and down, it will be 3 over 5. Exercise number 8. A box contains 5 white and 3 blue and 4 green balls. What is the probability of getting the following? First, I'm gonna find the total by adding all this number of balls. I'm gonna add 5 white plus 3 blue plus 4 green. The sum will be equal 12. So the probability of getting a white, I'm having 5 white balls over the total, which is 12. The probability of getting a green ball, we have 4 green balls divided by the total, which is 12. We can simplify this by dividing by 2. 4 divided 2 equal 2, and 12 divided 2 equal 6. By dividing again by 2, 2 divided 2 equal 1, and 6 divided 2 equal 3. We just simplify the fractions, because if it comes in a choose, it will be in the simplest form. The probability of getting not white, so we don't need the white ball. What other colors that we have? We have a blue and green. The blue balls are 3 and the green balls are 4. So to get blue or green, this is 7 balls over the total, which is 12. Question number D, getting a blue or green ball. The number of blue is 3 and the number of green is 4. It's the same, so we're gonna have 7 over the total, 12. The probability of getting a black ball, there is no black balls. This is an impossible event, which equals 0. Our lesson is finished. Don't forget your homework in the booklet, page 82 and 84. Then you have to solve the quiz in page 85, and see you in another video.